Bobette Hunsicker here. We're going to be doing some area of triangles today. Your assignment is going to be a little bit different, but your assignment is to do the Mad Lib, but I am going to show you how this works before you're able to do the Mad Lib. So there's a couple of things that we need to go over as far as the area of triangles go. So let's go ahead and take care of that. So first of all, you know how to find the area of a triangle way back in the day. You know that it is 1/2 base times height, right? Base times height, divide by 2, okay? We also know now that the sine of C, so if I go over to this triangle and I look at the C, angle C, the sine of C is going to be the opposite, or H, over hypotenuse, which is A, okay? So then if I go solve for H, right? If I solve for H, I'm going to get A times the sine of C. And what I can do is I can come up here to my area formula and I can substitute that in. So I'm going to take my H out and I'm going to put in an A sine of C. Okay. I am going to write, though, A first. So you do A times B times the sine of C. So this is the 1/2, right, base times height. Okay, so basically, if we go look at our triangle, you're given 2 sides, A and B, side A, side B, and then the angle C that is in between it. So this works when you have side, angle, side. Okay, so let's go try some. Here we go, number 1. We're just going to do 1/2 times 15 times 12 times the sine of 110. It's that easy. Nothing else to it, I promise. 15 times 12 divided by 2 times the sine of 110. And it doesn't matter what order you put it in. Again, I want nearest tenth. So I'm looking at 84.6. Done. Number 2, I have this angle. I have 3 sides. Again, we need a side angle side. So make sure that you're using the right numbers. So we're going to do 1/2 of 6 times 8 times the sine of 72. So you know by now, right? Please make sure that you are showing your work. You're writing all of this down. You're telling me what you're punching into the calculator. I actually want to see the formula, 1/2, which 2 sides that you're using and which angle you're using. Because you know how it is. It never stays super simple. Okay? All right, let's go take a look at number 3. We have a side, an angle, and a side, so we can do it. Let's go take a look at number 4. And by the way, I'm not walking you through all the way this one. This is going to be pretty straightforward. Let's go take a look at number 4, though. I have this side and I have this side, but I'm missing the angle in between. And so you know that there's 180 degrees in there. So let's go figure out what that missing angle is. Okay, so 180 minus 81 minus 43 gives us 56 degrees. So we're going to use 1/2 times 34 times 49.2 times the sine of 56, and whatever that is. Okay. Number 5, same thing. You have to go get this missing angle, so you're going to have to subtract from 180. Okay. And that's going to give you, it looks like 125 degrees. So make sure that you're doing 1/2 of 17 times 14 times the sine of 125. And again, whatever that gives you on the calculator. Okay? All right, I'm going to go ahead and pause the screen. I'm going to go put those numbers in and do the second page. All right, for those of you that did not like the way that Bobette finished that paper, here you go. Number 3, you should have gotten 119.2. Number 4, and then number 5. Again, please make sure that you are writing down the actual formula. That way I can help you. If you just put down a 7 and a 17, who knows? Maybe somehow you brain farted and said that 1/2 of 14 was 6. Okay, so again, make sure that you are writing everything out. Let's go do the second page. All right, so here's where it's going to get a little bit hairier. The first thing that I want you to notice is that up at the top, I scratched out the law of cosines, and this is where it's going to be really evident to me if you have watched the video, because I'm going to give you something different besides the law of cosines. Law of cosines is next week, and I'm going to show you a different formula to use for this week. So let's go ahead and do number 6. Remember that the formula is 1/2 AB times the sine of C, and we need to have a side angle side. And if you look, I've got a side, but I don't have the correct angle. So I need to go find that angle, okay? Well, how do you find that angle? What have we been doing? We've been doing the laws of sines, so let's go do that, okay? I have an angle that is 93, and I have a side that's across from it. So we're going to do the sine of 93 over 12 is equal to, it looks like I'm going to have to find this angle first. So let's just call it the sine of B over 7. We're going to call this angle B, okay? And let's go see what we get. So using the handy dandy calculator, 7 times the sine of 93 divided by 12. The sine of our angle is going to be about 0.58-ish. I'm going to go ahead and second sine that to get the angle, and I get 35.6. All right. All Snapple-T. Right? So we got to do that. 180 minus 35.6 is going to give us 144.4. Whoops, I left a 4 out of there. Let's go squeeze that in there. 144.4. So I need to figure out which one of these is going to work, right? So if I did 35 plus 93, I'm going to get something less than 180. I have room for angle C, okay? So this one's going to work. What about that 144? 144.4 plus that 93-degree angle that I had before, that's going to give me something that is bigger than 180, so it's not that angle. So I know that angle B is 35.6. So now I just need to find what angle C is. So I'm going to do 180 minus. Okay. So 180 minus the 93 from before minus the 35.6 that I just got, which means that this angle inside here is 51.4. And that is the angle we're going to use in our area formula, okay? So I'm going to do 1/2 times 7 times 12 times the sine of 51.4. Okay, and we should get 32.8. All right, let's go do that again, okay? So number 7. I have this angle, which means that I can get this side. I have this angle, which means that I can get this side. But then I have this side, which means I would need this angle. Oh, well, I can get that angle pretty easily, right? So let's go figure out what that angle is. So 180 minus 114 minus 28 gives me a 38. And now I can go find out what one of my other sides is. So it shouldn't matter which one that you do. I'm going to go ahead and use the 114, okay? And I'm going to find out what this side x is. So I'm going to do the sine of 28 over x is equal to the sine of 38 over 20. And I get a 1525. Okay? So now that I have 1525, I have a 20, and I have a 114. Holy bananas, look at how much I have marked up this triangle. So we're going to do 1/2 of 15.25 times 20 times the sine of 114. Oh, love that calculator sound. 139.3, okay? Okay, so I paused the screen really quick and I just wanted to show you that it doesn't matter which side you actually do first and which side you actually use. And so I went ahead and I called this side over on this triangle Y, and I used the sine of 38 over 20, and I used the 114, and then I figured out that this was 29.7, okay? And then I just chose to use the 29.7, the 30, and the angle 28, that SAS, to figure out what the area of the triangle is. Now, it's not exact because I rounded the 29.7. As a matter of fact, in my calculator, you can see it. It should have been 29.6768, right? And so I rounded a little bit, and so that is part of the reason why this number is not exactly identical to this number. It's just a rounding issue, but it doesn't matter. If you're finding the area of the triangle, that area of that triangle is not changing, okay? Okay, so you're going to do the same thing with number 8. I will, in a couple of minutes, freeze the screen and show you, and you can check number 8, but I want you to do this one on your own. What I do want to talk to you about is number 9. That's why it's got a star by it, okay? Okay, so this is where it's going to be really evident who watched the video and who didn't, because I don't want you to do the laws of sines. I want you to use what is called Heron's formula. If you notice on number 9 and number 10, we have the 3 sides of a triangle. And so we can use Heron's formula. Heron's formula is actually named after the Heron of Alexandria. And he's the one who derived this formula from the laws of cosines, which again is next week. But here's what Heron's formula says. You're going to take the square root of, and you're going to do S times S minus A times S minus B times S minus C. Now, A, B, and C are the sides of the triangle. So A, B, and C are going to be 21, 15, and 23. But S is actually half of the perimeter. And so if you know all 3 sides, you can add them all up, divide by 2, and then you can just plug this in, okay? So let's go do that. So let's go find the perimeter first. Okay, I'm actually going to find 21 plus 15 plus 23. So I'm going to get 36, 86, 89. And so S is going to be 89 divided by 2, which is 44.5. Okay, so we're going to do, so Heron's formula says that the area is going to equal 44.5 times 44.5 minus 21, whatever that is. Okay, 23.5. We're going to do 44.5 minus 15. Which is 25.5. And then we're going to do 44.5 minus 23, which is 21.5. Okay, I'm going to multiply all of those together and I'm going to square root it. So let's do it. 44.5 times 23.5 times 25.5 times 21.5, square root that big old honkin' answer, and pa-pow, 757.2. Okay? All right, we're going to do the same thing with number 10. Let's go find S. So S is going to be 17 plus 22 plus 16.5 divided by 2. Which should give you an answer of 2775. And let's go plug it all in. So the area is going to be 2775 times, I'm telling you, sound effects help. 27 minus 17 is going to be 1075. 27 minus 22 is going to be 575. and then 20